Hello everyone, welcome to my channel Hypermesh Basic to Advanced. To give a bit of a background about my channel, I make videos related to FEA and Hypermesh on this channel. So if you're looking for a channel where you can learn new things about FEA and Hypermesh, don't forget to subscribe my channel and follow for regular updates. And if you are already following my channel and not subscribed, please consider subscribing to help me and not miss out on any updates. Okay. So coming on to the topic of this video. So in this tutorial, we will be performing Bolt Pretension Analysis, right? For this, we will be using a bracket, as you can see here on the screen. There's a bracket here, right? So I have already meshed this bracket using quad elements, if you can see here, right? Using 2D quad elements. So first things first. So what is pretension analysis? So to understand this, we should first understand how does fastening work. So suppose you're fastening some part in between these two flanges of the bracket, right? So we'll put the part in between and we'll put a bolt through it and we'll fasten it, right? So how does the bolt fasten it? So when we tighten the bolt, what happens? The bolt applies a compression load on these two flanges of the bracket, right? And according to the law, there's a equal and opposite reaction, and the bolt feels a tension force as it is applying a compression force on this flange of the bracket. The bolt feels a tension force, right? So that is why this analysis is known as bolt pre-tension analysis, right? Okay. So in this, as I told, I have already meshed the bracket using quad 2D elements, right? And I have created the bolt using a 1D beam element. As you can see, it's this green color element here. It's written as C beam here, you can see. So to create the beam element, we can just go to this 1D, if you can see it here, and we can just go to bars, right? And then we can select element type as C beam, and then we can select the two nodes in between which this bolt or beam element will be created, right? So for these two nodes, I have used these two RV3 elements which I have created to connect all the holes on the edge of all the nodes on the edge of this hole, right? So we can just select these two master nodes of the RV3 elements and we can create a beam element, right? And for creating a beam element, we also need to specify the beam property. So what is a beam property? Beam property basically consists of the dia and section of the beam, right? So for that, as you can see, I've already created a beam section collector here. You can do this by just right clicking on this white browser area and going to create and going to beam section collector, right? And then you can there's a beam section under this. So if you see here, the radius of this beam section is 5, right? If you can see here, just the radius is 5, right? So this property will be used while creating this beam element, right? So actually this beam section collector is not directly used, property is used there, right? So after creating this beam section collector, we'll just go to properties, right? And we'll create a new property. I've already created a beam property here, if you can see, right? This yellow color, right? So if you see here under this property, I've used the card image as P beam L, right? And material I have selected as steel, right? And beam section is the place where you specify this beam section collector, right? Which we had created earlier, beam section. We are going to reference it here, and then we are going to apply this beam property to the beam element when we are creating it, right? So this is how we create the bolt, right? And for the bracket, I have used the shell property, if you can see here, and I have assigned it as thickness of 4, right? Yeah, so I have assigned it a thickness of 4, if you can see here, and the card image is special as it's a 2D part, right? So next, the materials we have used here. So for the bolt, I've used steel, as if you can remember, here I've showed you under the beam property, the material is steel. So I've used steel as the material for the bolt and aluminum as the material for the bracket, right? So for that, we can go to components and we can just go to the surface mesh here. If you see under the property, we have shell property, right? And the material is aluminum. For the bolt, I've used the property as beam property, right? And the material as steel, right? So we have the meshed model of the bracket. We have the bolt created and connected to the free edge of the holes using the RB3 elements, right? So next, we have the materials also created. We have the properties created. So what is next? So next will be, we need to create constraints for this analysis, right? As we have done for previous analysis. So what will be the constraint? So here we are fastening the bracket, or we are fixing the bracket on these 4 corners, if you can see here, right? So what we'll do, we'll fix all the degrees of freedom on these 4 corners, right? So for that, I have created a load collector named constraint, if you can see here, and I have constrained all the degrees of freedom on these 4 corners, right? Created a rigid element, RB2 element, and constrained all the degrees of freedom of the master node, right? So we have created the constraint, right? Now we have to apply the load also, right? So since this is a pretension analysis, the load will be applied a bit different, right? So for this, we can go to the tools here, if you can see, beside setup, go to tools, and we can just go to pretension manager, if you can see, right? We'll just click on the pretension manager. Fine. So here, if you can see, I've already created the pretension load. That's why it's showing here. If you can see 1D, bolt ID, element ID, surface ID, and load type is force. I've created a force, right? And load collector is a pretension, right? And the magnitude of the load will be 400. Okay. So we'll just modify this. So for your visualization, so here it's previously it was 500, right? So we are going to modify it to 400. So we'll just click on apply. So if you see, it has changed to 400, right? And then we'll click on OK, right? But before that, I'll tell you how to create a new pretension load, right? For that, you can just go to add 1D bolts, right? Because this is the 1D element. So we'll just click on add 1D bolt, and then we have to select the element, which 1D element we are going to apply it to. We'll select this beam element. We'll click on proceed. You see there's a new line here, and you can just assign the respective values. What will be a load type, right? What will be a load collector? If you want to create a new load collector, or you have an existing one, okay, and you can give the load magnitude, right? So for now, I'll delete this because I've already created one. Okay, and we'll just click on OK. Okay, so you can see the load will be applied something like this. You can see it here. So okay, I'll just change the color just in case if you're unable to see it properly. Okay, so you can see it here. I've put it in orange color, right? So basically now we have the meshed model, right, with the materials and properties applied, and we have created the constraint, we have applied the load, right? So what is the next step? So the next step would be to create a load step, right? The load step, which is used to combine the constraint and the load, right? So I've already created a load step, if you can see here. So I've named it linear static, as the analysis type will be linear static. Okay, we'll just expand this for better visualization. Fine. So analysis type is linear static. So we'll reference the constraint load collector under the SPC field, and then here under the load field we won't reference anything. So this is going to be a bit different from the previous analysis where we reference the load under the load field, right? But since this is a pretension analysis, there is a separate field for pretension. If you can see here, it's written pretension. We are going to reference the pretension load collector under this field, right? As you can see, I've already referenced it. Okay, so we have created the load step. Fine. So we have the mesh model, we have the properties, we have the material, we have applied the properties and materials, we have applied the constraints, we have applied the load, we have created the load step, right? So what will be the next step? So next step is to run the analysis. So for that we can just go to analysis here, okay, and we can go to Optistruct. Okay, so I'm using Optistruct for this tutorial. If you want, you can try it out with any other solver, right, of your choice. So you might have to select some different cards. Same cards might not be available, right? But for the time being, we are using Optistruct. So here under Optistruct, input file, okay, this will be the file name, right? So export options will be all. Run options will select as analysis, as this is an analysis, right? And memory options is memory default, options opt skip, okay, fine. So we'll just then click this Optistruct button to run the analysis. So once you click on the Optistruct button, pop-up window like this will appear, right, which will show the progress of the solver run. Okay, so since this was a very simplified model, we have the run completed already, right? You can see a job completed, message for the job analysis completed, and we have some summary here, right? Okay, so we can just go to view and click the drop down next to it and view the output file. And if you want to visualize the results, then just click on this results button, which you can see here, and then we can visualize the results. So I'll just click on this results button. So once you click the results button, a hyperview window like this will open, right? So here you can see we have the bracket, right? And we have selected the result type as displacement. And you can see here how it's looking. So there's some displacement legend here, right? And if you want to see the animation, you just click on this run animation, right? And we can see the animation. So there's a slight movement, if you can see, and just notice, right? See, there's a movement, right? So if you can't see it, we'll just magnify it a bit, right? So we'll just put it to 10, suppose. Okay, and we'll just see how it's looking. So you can see it now, right? We have magnified the displacement and you can see it clearly, it's moving, right? So what is happening, basically the bolt is applying a compression load on the flanges of the bracket, right? You can see it bending inwards, right? You can see it, right? So this is what happens when you fasten a bolt, right? Okay, so basically this is the displacement. So the mass displacement is around 0.4 mm, right? 4.1 into 10 to the power minus 1, right? So we'll just see the stress if we can. So element stresses, right? And we'll just select components and we'll go to displayed. Just click on apply, right? So here you can see this is how the stresses will look like on the bracket, right? So there are certain regions on which the stress is very large, right? This red region. Okay, so this is basically how you do a bolt pretension analysis, right? You can also view the stresses on this C bar or C beam element, right? So if you can see here, so we can also view the stresses on the C bar C beam element, right? By selecting through the drop down, right? Okay, so this is how basically you can perform a bolt pretension analysis, right? So hope you liked the video. You got to learn something new. So if you got to learn something new, you like the video, got to learn something new, then please consider subscribing and please like and share so that it reaches out to more people and more people can see and learn. Okay, so this is all for this video. See you all in the next video. Thank you for watching.